amazing people, two of our all-time favorites. We have Will first up. So there was another Will from the Netherlands. I don't know if you were here in the morning, but somebody is or was here. So I was like, I know a Will from the Netherlands. Marino from Toronto. Oh my gosh, these are my ride or dies here. This is so fun to see you, and thank you. Will is a Cube Crash vet, but Marino, your first Cube Crash, right? Oh, and your mic is not working. This is a problem that we have been having. If you can't get it to work, you may have to go out and come back, like all the way out and come all the way back. This happened a lot last Cube Crash. So we'll get Marino back in here. But yeah, Will, you want to Will's also a CNCF ambassador, so we've known Will for a long time. And your last gig, I don't have your new one, but your last gig for many years, Will was behind the team at SUSE and Rancher and knows a lot about edge technology. Second cutest mascot, next to my orange friend here in tech. Reno, is your microphone working?
Can you all hear me?
We can, thank goodness. And
Excellent.
I think this is your first Cube Crash.
It absolutely is. So I'm excited to be here. And
took you so long to join the party. He's like, tell me about it. Anyway, we did mention earlier for the Toronto team, there's a lot of folks from Montreal and Toronto. There is a meetup in Montreal tonight, so they may be jumping pretty quickly. But for everybody in the Toronto area, Marino is helping us host the CNCF holiday meetup in December. I think it's December 9th, and we're hosting it at the Intuit office for the CNCF community there. And we're going to make sure we get Archie and a whole bunch of the Canadian user groups from all over Canada, hopefully to come in and celebrate the holiday year-end event. So if you're in Canada, check that out on a CNCF community page near you, or hit up Marino for the user group he runs. And we're going to leave because I could just talk to you two all day. You know how much I love this team. So we're going to jump out because I'm really excited about your talk. So let's go.
Fantastic. William, how you doing, man?
Hey, I'm doing good, Marino. How are you?
I'm good. And to the audience, how are you all doing? I'd love to hear where you're all dialing in from, and tell us a little bit about what you've seen today and what you're excited about, and how Cube Crash has been going for you. We've got an interesting presentation, but I will give you all a bit of a warning. William and I did not really prep like most people would. We just hopped on a call. I think it was on Friday for maybe 10 minutes. And we're like, hey, we're going to talk a little bit about this and that and whatever else. And then we just put together a slide deck, and we want to keep it more conversational, as if two people were just chatting and debating situations around Sidecar and sidecarless. So I'm going to go ahead and share my screen, and let me know when y'all can see that. Yes,
you
should be able to. Okay, I wish this would go full screen, but that's okay. Anyways, what we're here to really talk about is just really thinking about, if you wanted to pick a service mesh, would you go the sidecar route, which has been around for a really long time, or if you would take the sidecarless route? And both have upsides, both have drawbacks, and it really comes down to your operational needs and where you're trying to go with your applications and microservices. So I'm going to just quickly introduce ourselves. Will you want to go ahead?
Sure. Thanks, Marino. I'm William. I'm based in the Netherlands, as our friend Liz Marie said. I am a strategy lead at Mirantis. I'm a CNCF ambassador. I'm also a Linkerd ambassador, so you know where my heart is. On my day-to-day, I go from helping customer implement their strategy, long-term strategy, as well as working on the nitty-gritty tactical items. And I specialize on platform engineering, on edge computing, and of course, like everyone else in AI these days.
That is awesome. I'm going to try and present a different way and see if this actually works. Start from, oh gosh, now I lost my, that's fine. That's no big deal. I think y'all can see.
Yes.
So, a little bit about myself. I'm a solutions architect at a company called Kong. And what we do is really focus on the overall API lifecycle strategy. And it's not just about APIs. When you think about the space of AI and LLMs and what's going on with Kubernetes and the whole microservice ecosystem and CNCF ecosystem, it's all tied together through a set of APIs, and you need some sort of system in place to be able to help with that level of governance and guardrailing, if you will. And I'm also a CNCF ambassador. And as Lisa had mentioned, I'm based in Toronto. So we run a meetup group here as well. We just had a meetup last night. We celebrated our 10-year CNCF party as well. It was a fantastic event. And I think it went really well. Like overall, I think the entire crew that showed up, we had about 165 people come to the event. So great event overall. Very happy how it all turned out. And like Lisa mentioned, we've got another one at the Inuit office. So if you're in town December 9th, come by, hang out. All right, let's talk a little bit about what a service mesh is and what sidecars actually do for us. William, you want to take that one?
Yeah, sure. What is a service mesh? So, in the lamest terms as possible, a service mesh is a fabric that connects services in one or multiple Kubernetes clusters. How does it do it? It provides service discovery. It connects endpoints and facilitate and modulates the traffic and the routing of and the policing of this traffic through the cluster and outside the cluster as well. Um, the service mesh, the sidecars. So what are sidecars? It's funny because until Kubernetes release 132, or 131, I don't remember. There was um, no first class uh, term to define to first class object as a sidecar, but we all called it like this. But there was no, let's say, first class citizen as a sidecar, so there were no policy or how that first class citizen should be, um, should the life cycle of that first class citizen should be, right? So, but anyway, a sidecar is a container that exists inside a pod and does work that supports the life cycle or the life of the application that another container might be uh, pursuing or exploring. In the context of service mesh, a sidecar intercepts the traffic that is destined to the other containers, which is, let's say, an application, and it manipulates this traffic or enriches can enrich the telemetry, can modulate the traffic, meaning can do some circuit breaking, can do some traffic splitting, many things that we probably will be speaking about today. And the service meshes and sidecars normally work a layer 4 and layer 7 of our good old TCP IP stack. Um, and yeah, I think Marino, this gives a bit of an intro of what a service mesh and a sidecar is. Does it?
Yeah, I mean that's a fantastic intro, and just to extend that conversation a little bit, when we think about some of the traditional networking patterns that we used to have, surprisingly, a long time ago, we had a very similar model. There were a lot of servers out there, hardcore hardware servers, bare metal servers, if you will, that had the TCP/IP stack, and I mean, a lot of them do today, but the actual logic for the routing lived on that server. And you'd wonder, like, why would we do that? Well, way back then, we're talking about like 15, 20 years ago, the patterns for networking weren't very evolved. And we started to see that it became very, very challenging to try and individually manage networking for a lot of these servers. So they centralized this routing to what we call a router or a gateway. And so servers would just point their traffic towards something called a default gateway and route across the network and find other servers too. And then you throw in DNS into the mix, it becomes much more findable or searchable, if you will. And when you think about what a service mesh is there to do, it follows that same architectural pattern where you have services that need to find each other, they need to know how to get to each other and communicate with each other. But then you're layering some additional capabilities like the encryption bit. So if I've got traffic going between two different services, front end to the back end, we just don't want to send that request in plain text. We have to protect it somehow. And so a common use case of service meshes today is using something called mutual TLS, where both services need to authenticate each other and form an agreement, negotiate that they can communicate with each other, and that entire path becomes encrypted altogether. Now, when we think of a service mesh, we don't do this right at the application layer. We don't do this at the service layer, primarily because every time a network has to change or the number of services you deploy to your environment change, we don't want to be redeploying that code stack. And so we do this at the sidecar proxy, which typically is either a Rust-based proxy or something like an Envoy proxy, which is a very small footprint deployed to, in Kubernetes speak, a pod. And it lives alongside that main application container. And that logic just gets derived from this control plane that lives up here. You tell it what you want it to do, follow that declarative manner, and now your services can talk to each other in a very secure manner as well. And along the lines of what William said as well, you're able to control your releases a lot better too, because you can decide things like traffic splitting, how you want to split up your traffic based off of certain conditions. And you might be trying to test out new features without really impacting an existing service space, if you will. So what's happened in the last several years, let's say 3 years, a new pattern has kind of emerged, which actually closely resembles a very old legacy pattern where you remove the proxy logic or the routing logic from where that pod lives, and you place it external, you co-locate it and you place it external to those services or servers or systems that you're trying to access. And what we call this today is the sidecarless pattern, where you still have that functionality of a service mesh, except that sidecar pattern no longer lives alongside your pod. It lives as another pod in, or a set of pods inside of your cluster, and they're still processing traffic the same way. Now, interestingly enough, when you think about the way a service mesh handles traffic, we're not just looking at TCP/IP, we're looking at HTTP headers. We're trying to route based off of layer 7 intelligence and data that we can gather about a service, because we might plug in some additional parameters that help a service route a certain way. So some of the patterns we're starting to see now with a sidecarless pattern is where that layer 7 bit and layer 4 bit gets split up. And you start to see this because you have organizations that really think about the cost of running a sidecar. If you've got 1,000 microservices inside of a Kubernetes environment, well, you've also got to consider 1,000 sidecars as well. And to a lot of organizations out there managing this at scale, it becomes a huge cost. It becomes a bit of an operational burden, and there's more components to think about and manage and maintain altogether. And so that's another one of those reasons why that sidecar pattern emerged. But here's the other thing too to consider. With a sidecarless pattern that you have, even though you remove that logic directly from, let's say, a pod and place it elsewhere, you still do see a lot of the service mesh capabilities and benefits, except when you start thinking about how advanced your services are, how they behave, how they communicate amongst each other, you still need to think about, do I get MTLS? You still need to think about that layer 7 logic, especially when it comes to retry logic or timeout logic, or if you're trying to do that release strategy, if you will. William, do you have anything you want to share about this?
I actually do. When one thing that I keep hearing, it is this cost of sidecar, that it can be cost us in actual money or actual CPU resources. When I talk about cost, I'm always talking about system resources. Um, we talk we think about Kubernetes. We thought about Kubernetes always as the so in Kubernetes the atomic unit of work is the pod, is not the container. That's because a pod should perform a job, like in the good Unix terms, do one job but do it good. So that pod should do that job, and whatever is needed for that job to be accomplished should live in that pod. Now, the cost of the resources that are used by a sidecar, unless very, very much edge cases, very particular cases, I have never seen it being a burden to the system. What I'm thinking though as well is this shifting the proxying, because we are still proxying, right? I mean, the site we might be taking away the proxy from the pod and put it in a, I don't know, a waypoint, or putting it on the node, thinking how the CNI of Kubernetes work, right? I mean, every node is its own network. Let's go with that. Um, we are proxying now at layer 7, as rightfully the image says, and as Marino said. But we are also increasing the uh, deepened communication. So everything that has to happen between the application services needs to go through those waypoints, to those proxies. So my question is, and of course, it maybe, I mean, it's a very open question, but we are trying to be more effective with the cost optimization of resources. So therefore, we try to remove the sidecar. But aren't we uh, pushing more requests across this entity as a proxy, doing so? Because wouldn't that wouldn't more requests be processed? Because the deeper are this request, the more responses have to be handled by the proxy, right? I mean, Marino, you are way more an expert than me on service meshes, but this is how
Well,
the proxy would work.
yeah, I mean, you're hitting something that's very important, right? You mentioned it when we were chatting on Friday, and it's really where that tax goes. So if you remove the tax from the pod and then put it elsewhere, that taxation still is pretty much there. You're thinking about a shared proxy either across a set of nodes or on a node per node basis, and you're thinking about a larger blast radius of what could go wrong. Now, okay, yes, we're operating in the world of Kubernetes, and Kubernetes has a very quick reconciliation process to ensure that
And nothing
something that
goes
should be
wrong in Kubernetes.
well, that's
And
just it, right?
nothing goes
Nothing
wrong.
normally goes wrong. Yeah. And so when you have something that's a shared resource, now you have to compete. There's no quality of service, actually. There's no real quality of service when you think about a shared resource, because you cannot say to one pod, hey, I'm going to take X amount of resources, give it to you, and then another pod gets starved of that. And so you start to think, okay, yes, I might be initially saving a significant amount of CPU and memory at a per pod level. I'm now having to compete for resources elsewhere and think about how I want to communicate across the wire when maybe my proxy, my L7, my layer 7 proxies heavily utilized, it's heavily taxed, it's at its max utilization. Maybe we forgot to set the HPA on Kubernetes, so it's not scaling as we expect it to. And maybe even the VPA is not available for us to be able to scale up. And so sometimes you start to think, like, if I'm operating an application that needs to scale up in its entirety, especially during certain times of the day or maybe throughout the year, you might run into situations where it doesn't scale as you expect it to. And now you start to see higher latency across different services. And then you start to think about your deep service calls. So there's a mindset that every time we'll build a bunch of services, they act as stubs, meaning I've got one service and it just gets exposed, and then I have another service that might communicate with that first service and it might not be exposed. But sometimes you have applications, because of the way they've been built, that go several calls deep. And if you start to think about that layer 7 logic, if you start to think about how much layer 7 action I need, I have to go up to a layer 7 shared proxy every single time. So I'm actually adding more hops back into my overall connection. Whereas when you think about the original sidecar pattern that exists, every one of those sidecars are dedicated to that specific resource. And sometimes you have to think, like, okay, well, maybe not all my traffic might be L4, or sorry, it might not all be L7, it might be L4, and that's fine. But you have to go through that exercise to determine which of your microservices are actually strictly L4 and which can benefit from L7. So there's a lot of different considerations. We can go on and on about the different conversations around which one would you pick. So we just really want to leave you with some guidance as to what you should really consider. Oh, my mouse stopped working. Okay. When you want to consider a sidecar pattern versus a sidecarless pattern. And so, William, why don't you walk us through some of these considerations?
Yes, I will. But before I do that, I want to put an overarching thing that I strongly believe. Regardless of the model that one chooses, the service mesh should work towards one objective, one very strong objective, in my opinion, which is um, abstracting the cluster topology from the applications. The applications should not be addressing the cluster topology, should not be affected by the cluster topology. And the service mesh, regardless of the uh, pattern that we choose, should should help with this. So thinking about that layer 4 and layer 7, and where is the proxy, the application should provide these requirements, as in I mostly need layer 4 or I mostly need layer 7, and the rest should just happen. And we uh, service mesh experts or platform experts should have a platform that handles that the traffic requirements of that application um, transparently. Now, when we talk about sidecar, um, obviously we do have we do have the possibility um, to provide to the application with additional telemetry, because the container of the application of the sidecar, um, sorry, this sidecar is sitting just beside the container. It is intercepting in egress and ingress traffic to that application, and doing so can additionally can add additional insight into the requests and the responses that the application is providing. From the sidecar-less model, we don't have this. We don't have anything sitting beside the container, right? So we can provide we still can provide telemetry, but we provide a layer 7 request based telemetry rather than let's call it on the wire telemetry. With Sidecar, when things go wrong, um, the blast radius, as is nicely put there on the slide by Marino, it's on that application, uh, on that container that is on the set of sidecars that are forming around those that one application or multiple applications. However, when something goes wrong on the sidecarless model, is the waypoint. I mean, sorry, I shouldn't call it waypoint. I should call it that layer 7 proxy that is for the cluster or for the node. So whatever is happening, it's going to happen to everything that it's using and consuming that waypoint. Uh, for the for the rest, I want to give it to you, Marino. I see some stub services and DeepL7 call that I know that you are passionate about.
Yeah. Yeah, I mean, I've done some work with a few clients, and we've done some extensive testing around how performant a service mesh is when you have very deep layer 7 calls altogether. And let's be real, right? No one just simply builds their services as stubs or with 1 to 2 calls. I've seen this one particular client that has roughly around 50 calls in their call chain. And obviously, that's not a best practice. It's not ideal, but it was the way they built their application. And you have to think in those particular circumstances, if every one of those calls have to hop back to a layer 7 proxy, it's not ideal. Now, the other situation really comes down to the fact that if your services are very simplistic in nature in how they call each other, and if they're mostly stubs, which means they don't really have any deep call chains, you'll probably benefit from a sidecarless mesh altogether. But also, one thing I would recommend is if you're really looking for a very neutral evaluation, because I work for a Kong and we have a sidecar based mesh and we have sidecarless based models. If you really want to think about how you want to design your architecture, but there's a really good CNCF ambassador, Henrique, who works for Dynatrace. And he did a talk that compared a number of different service meshes. He did it at Rejects, and I think he's also presenting it again at KubeCon, or a variation of it with some more updated information. Go look up the Rejects talk. I think it's called the Service Mesh Wars. He really throws in some Star Wars themes as well. And it really gives you a very neutral, grounded view of like how you should evaluate a service mesh from an observability point. Now, I don't want to go too deep because I also want to be aware of the fact that Kazlin's going to be coming up in a panel very soon. Hi, Kazlin, how are you doing? And I just want to leave you all with one last thing: merge forward. I encourage everyone to go to the Slack channel, join us, join the cause for a variety of great causes around neurodiversity, deep roots, really thinking about the visually impaired and blind, deaf and hard of hearing, and really thinking about how we all work together to move and merge forward so that we can all work together very well in the CNCF and work on a variety of different projects and support each other. Scan that QR code, it'll take you right there, and we hope you join us there. And again, I just want to thank you all for joining us on this short talk about sidecars versus sidecarless. If you want to find us, William's LinkedIn. Sorry, I couldn't find all of your links. William, I was like trying to put this all together towards the last minute there. Feel free to scan our QR codes and connect with us wherever you want.
Thank you. Thank you.
Awesome. Thank you both for being here. We really appreciate you both.